Okay, so Leetcode practice time. In this video there are two goals. The first goal is to see how to solve this problem, and the second goal is to see how we should behave in a real interview. So let's get started. So remember, the first step in a real interview is to try to understand the problem, and if there is anything you don't understand, please bring up the question, and also think about some edge cases at the very beginning. So let's see, contiguous array. So given a binary array, find the maximum length of a contiguous subarray with equal number of 0 and 1. So take a look at this example, 0 and 1 output as 2. So the explanation is 0, 1 is the longest contiguous subarray with equal number of 0 and 1s. Alright, so the length of the given binary array will not exceed 50k. So I assume the input num array would be, the length of it would be anywhere between 0 to 50k. Okay, so after you understand the problem, it's time for us to find the solution. So I think the only useful piece of information here is within the subarray, what is the number of zeros and what the number of ones, or what is the diff between the number of 0 and number of ones. So I'm thinking about doing one pass through the input array to see if it's gonna work. So if we do one pass through the input array, and at the same time we use a map to keep track of this. So the key would be the number of ones minus the number of zeros. Yeah, and the value would be the smallest index. The smallest index within the input num array that has this diff. Yeah, so and in the future, if we encounter, okay, so we keep the hash map. The hash map has the key as number of ones minus number of zeros, and also the value would be the minimum index. So this is so for the key, it is computed from the start of the index until the current index we are looking at. So for example, if we have 0 1 0 1 0 0, so we are going to first of all put map as this is 0 minus 1 and main index as 0, and then we have 0, set the index as 1. And when we encounter another 0, we see that, so when we are at index 2, the second 0, the sum of the diff is equal to minus 1, because here we have 2 0 and 1 1, so the sum of the diff is minus 1. So we have another minus 1 in this hash map, so we can safely say that there is a subarray before that has the same diff. So we just need to get the index of it and use the current index to minus it to get the current length of the subarray that has equal number of ones and equal number of zeros. So that's essentially how the solution is gonna work. So the runtime for this solution is going to be all of n, and space-wise it's going to be all of n as well. So n is the length of the input num array. So let's do some coding work. So for coding, don't be too slow, and also care about the correctness and the readability. So let's define the int max length as 0. If nums is .length is equal to 0, then we just return the 0. Otherwise, it's time to go through the input array. So first of all, we define a hash map. So the map is going to be key is integer, value is integer. It will be div index as new hash map. So for the easiness of computation, we would just have a placeholder. We will put index 0 and -1. So I'll explain why I put the 0 and -1 later on. So now say div sum is equal to 0. So we are going to go through the input array and the ++I. So okay, so we will define the div here. So div would be so if nums I is equal to a 0, then it will be -1, otherwise it is 1. And then we compute the div sum. So if in the input, so if in the hash map there's no such div index, sorry, there is no such div sum within the div index, then we are just going to update the div index with the div sum and the corresponding index, and that contains key sum and div sum. Then we are going to div index dot put div sum, and this is I, and just going to continue. Otherwise, if it already has the div sum before, then we are going to get the corresponding index and do a minus. So we are just going to compute the length of the maximum contiguous subarray that has an ending index as I, will also have equal number of zeros and ones. This will be computed using I minus div index dot get div sum. Yep. So and the max length is equal to max length and the max length, and finally we return max length. So after we are done with coding, it's time for us to do some testing. So let's go through example 2. So at the very beginning, the max length is equal to 0, and the div index map is equal to empty. So we put a placeholder 0 to 0 and -1. That is because this is for the easier computation. So for example, if we have equal number of 0 and 1s, we just treat it as a valid subarray. So but if it is not contained in the div index map, then we have some trouble computing the length. So that's why I put a placeholder 0 -1. This is more for easier computation purpose. So when I is equal to 0, so by the way, I'm looking at this input array. So when I is equal to 0, the div sum is equal to -1. So we are going to put a -1 and 0 into it. And next time when I is equal to 1, we are going to have div sum as 0, and since 0 already exists in the div index, we are going to update the max length as 1 minus -1, which is 2. Current max length is this. and when I is equal to the last index, so we are going to have -1 again. So diff sum is -1 again. So we are going to say, okay, we are going to do 2 minus 0 here. So 2 minus 0 is 2, so we are not going to update max length. So finally we are going to return 2, which is expected. So I think this piece of code should work. Let's give it a shot. Alright, so div sum, okay, so there is a typo here. Alright, so I think it should work. Let me give it submission. Okay, so everything should work here. And regarding the test case setup, I would say maybe we can test a input array which is empty, and also set up something like example 2. I think that should have good enough test coverage. So that's it for this coding question. If you have any question about this puzzle or about the solution, feel free to leave some comments below, and I'll see you next time. Thanks for watching.